friends, I am Mr. Raj Gupta. Today, my topic is electricity. Hello, friends, it's my first lecture on YouTube. So, let's start with our topic, the most interesting topic electricity. Friends, the study of electricity it categorized into two basic parts. First one is electric current, which is most focused in our this lecture, and our second topic is electrostatic. Electrostatic means in this category we mostly study charges at rest, but electric current we used to study about charges moving in a wire or any conductor. Okay. First is starting with the raw facts related to electrostatic. We should know about the Coulomb's law. Coulomb's law states that if we take a charge, let us consider a positive charge which is at rest, it is fixed and it is immovable in any respect. And let us consider magnitude of its charge be capital Q. When we tries to move a same charge, positive charge, more closer to this one whose magnitude is small q, then this charge is going to apply a force in the opposite direction of its motion. Okay, then its electric field is considered as circular. That's why if a charge is at here or here on the same electrical wave, then the force exerted by it will be equal if the charge magnitude are equal. We will see that how it is. Let us consider it is moving in this one direction. Let us consider that it is here now. From here it is here. From point A, it is now point B. Let's say that the force exerted by this one capital Q charge on the small q charge be F, and the distance between them be R. Okay. Then Coulomb said the force applying by this one charge to this one will be proportional to their magnitude of their product of their magnitude, which is q or q1 q2 anything. And also we can examine it how it is possible. If we increase this one's magnitude of this charge, then the force exerted by this on this will also increase, and also when we increase its magnitude the force exerted by it will also increase. That's why their product. And another factor which is responsible for this changing in this force is the distance between them. If we increase the distance, then the force between them will decrease. And when we decrease the distance between their centers, then the force between their bodies will increase. That's why he said that the force is proportional to 1 upon r square. Okay, friends? Then 1 upon r square, combining these two proportionality equation, we got that force is proportional to q upon r square. Okay. To remove this proportionality sign, we used a constant k, q r square. Now Coulomb practically said that the value of this k will be equal to 9 into 10 to the power 9 Newton meter square per Coulomb square. How he said this practically? He put a Coulomb, 1 Coulomb charge at the place of this capital Q and 1 Coulomb charge at the place of this small q, and he take 1 meter distance between their centers. That's why the force, then he measured the force between them, and that force comes to be 9 into 10 to the power 9. Approximately. I'm saying you the approx value. That's why the K equals 9 into 10 to the power 9 meters square per coulomb square. That's all. And this one formula is derived from, and it is also said as Coulomb's law. That's all about the basic of electrostatic. Electrostatic generally refers the charges at rest. How a charges can be at rest? It is at rest when it is fixed at a point, or we have a common example of electrostatic force when we rub a comb with a wool or any cloth. It gets electrically charged. The electrons moves from the that cloth to the comb, and the comb is an insulator. That's why it doesn't allow the charge to move from one place to another place. That's why in scale or any comb, most commonly we have practically examined in our schools by rubbing a scale in our hairs and putting some paper clips here, and then that clips get attracted by it. Why does it happens? Because some electrons get accommodated at a particular place. It doesn't, scale is an insulator. That's why it doesn't allow that electrons to move from here to other places. That's why it accommodates it, and the protons present in them get attracted by this electrons that it get attached to them. Okay. Charges. By saying this word charges, or by saying this word electricity, what is the sense creates in our mind? Whenever we listen this word electricity, the common thing that's established in our mind is flow of charges, which is electric current. Electric current is considered as the flow of charges. Now, what is charge? Let me erase it. Now let us discuss about charges. Charges are mainly of charges. How does these charges form? When we have studied in chemistry that sodium loses one of its electron in its valence shell and it becomes Na plus. Means it get transformed from atom to ion by losing an electron, because the amount of proton get increased in its atom. That's why it becomes a ion. Ion is a charged body. Charge charge can be positive or negative. It can be neutral also, as we seen as in neutrons. Neutrons are neutral charges. Then charges are basically classified into protons, neutrons, and electrons. Protons are positively charged particles. Electrons are negatively charged particles. These all are the fundamental particles of an atom. Protons are positively charged. That's why we know that like charge repel each other and opposite charge attract each other. That's why proton and electron attracts each other. Uh, yeah, that's all about charges. Huh. Charges are additive in nature. We can add charges. Understood, friends? Charges are additive in nature. For example, when we are saying that, how can we say we have proved the atom is electrically neutral? Then we have taken a charge on an atom of an electron, charge of an electron, which is numerically equal to the charge of a proton. Okay, okay, friends. That's why the net charge on the body, the electrons have negative charge with the same magnitude as proton, but the proton they have positively magnitude charges. That's why they get cancelled with each other and neutron are zero. Okay, now discussing about electric current. Electric current are generally considered as flow of charges in or amount of charges flowing in 1 second. Amount of charges flowing in 1 second. Okay. Then from definition, we can say that electric current I is equals to Q upon T. When T is 1 second, then current and amount of charge passing through it in 1 second will be numerically equal, but their unit are different. The unit of current is ampere, unit of charge is coulomb, and unit of time is second. We all know. Then we got a formula I equals Q by T, Q upon T. From here we can write it also like Q equals IT. And cross multiplying it in that side. Okay, Q equals IT. The another formula, charge. The fundamental unit of charge, which is electron, it have a fixed amount of fixed value of its charge. That's why the charge on any particle will be the product will be the multiple of the charge on a particular electron. This Q charge can be positive or negative and belongs to natural number 1, 2, 3. It can be 0 also because charge can be 0. Neutron have 0 charges. Okay, yeah, that's all. That's all about electric current. Now let us define what is potential difference. Friends, potential difference. Difference means what? Potential at final minus potential at initial. That is potential difference. It is denoted by V. Potential V. Change in potential delta V. Okay, delta V. Potential difference. Here we can say that potential difference. Uh, it's just a feeling, friends. Words are very few to define what is potential difference. But we can say that, let us consider an example. It's a positive charge. It is fixed. Okay. Its magnitude is Q, capital Q. Let us say that at infinity, we know that at infinity, any charge can't apply any force on any charge which is at infinity at initial. Let the charge at initially, which is movable positive charge of magnitude small q, initially at infinity, which is initially at infinity. Then at infinity, there is no force acting on it. Its potential will be 0. What is potential? We have in our common life, we have generally listened about potential, like your potential is to do this, your potential is to carry that, something like this. Means potential is generally refers to ability, but here potential is little different. Potential difference means the minimum work done to move a charge, move one unit positive charge from A position to B position. Okay, let us consider at infinity, it is initially at infinity, and that point is A. Now it is here after some time at point B. We have applied force because it is also applying force. That's why we have to apply force on it to keep it from one A to B. That's why we applied force. We had some displacement. Then we did some work, and that minimum work, what is the definition? Goes on the definition. Just imagine minimum work done to carry One unit means what? One unit, one coulomb or whatever. Yeah, 1 unit. 1 unit positive charge from point A to point B. 1 unit potential difference. Work done. What? Some relation is coming from this statement. That is change in potential. Change in potential difference is equal to the minimum work done to carry 1 unit positive charge is equals, we can say negative charge, then potential come negative. Potential difference equals minimum work done or work done to carry 1 unit charge, that is delta V equals the work upon charge of whose charge? This charge. Now the potential difference compared to this charge, this make the body to have put some potential at point B. At point B it has some potential VB. At a point VA equals 0 because no force is acting on that object. Now from here we can say that the work done equals delta V into multiplied to the charge which is moving. Now delta V final minus initial. At finally it is VB and it adds initially it is 0 Q work done. Then when we said we are carrying the object from infinity or we are carrying the charge from infinity, then at initial position its potential will be 0. And we can say from here that VB into Q equals work done for this situation. Okay, that is about potential difference.